So today we're going to look at this question under simple harmonic motion that involve a little conceptual knowledge of simple harmonic. I will start by drawing the diagram, then apply the necessary principles that will enable us to calculate the work done in it. So as you all know, we have a pendulum bulb weighing 0.1 Newton, and the pendulum is always in kilograms. So I'll convert that 0.1 Newton to kilogram by using weight equals to mg, which is mass times gravity. Therefore, the mass now will give us weight over gravity, which is simply 0.1 divided by 10, and will give us 0.01 kilogram. This is now the mass of the bulb. Okay, so let's say a bulb of weight 0.1 Newton is hung from a massless string of length 50 cm. So let's illustrate that in a diagram. A weight of mass 0.1 Newton, but this time around we're replacing the weight now with 0.01 kilogram, which is the mass of the bulb. So I'm going to have a situation like this. This is now the, let's say this is the simple bulb is suspended here with a mass of 0.01 kilogram, and the length of this string is 50 cm. The length of the string is 50 cm. So let's continue. You say a variable horizontal force which increases from 0 is applied to pull the bulb until it makes an angle of 60 degrees with the vertical. Take note of that. It makes an angle of 60 degrees with the vertical. So this bulb now is pulled. Let's assume it's pulled in this direction and released. Then they form an angle of 60 degrees here. Don't forget, here, let's call here point O, point B, and point A. So no doubt, O to B is also 50 cm because it represents the same massless string. So let's go back to the question. Now we're asked to calculate the work done. The work done now, we do not know. We use our W. We don't know. So from here, by oscillating the ball from point A to point B, there's a height in this point. By making this oscillation from here to here, there's a certain height from this point. So the height will fall under this region. Here is the height. So let's call it H. We don't know the height. At point V, PE is maximum and my V is 0. Then at point A, PE is minimum and V is maximum at this point. Then H here is 0. H at point A is 0. So to determine the height now at this point, we need to get the height of O to, let me call it point C. Let's get the value of O to C in triangle OCB. There's 90 degrees. Let's get the value of O to C in triangle OCB. So I'm using adjacent hypotenuse. Adjacent hypotenuse, that is cos. That is cos theta. Give us adjacent hypotenuse. So I'm going to have cos 60 degrees. It's equal to the adjacent, which is my OC. The hypotenuse now is 50. So my OC will give us 50 cos 60 degrees. So OC is simply 25 centimeter. That is the value of OC. So if our OC is 25 cm and the length of the string is 50, what is now the height? The height represents the distance from A to C. The height represents distance from A to C. So if I use line analysis, I'm going to have line OA is equals to line OC plus line CA. So here is now 50. Here will give us 25 plus h, which is the height. Therefore, so now implies that my height is 50 minus 25. The height equals to 25 cm. That's now the height of the oscillation. So with that in mind now, we can calculate the work done now. So the work done is at point B, because at point A, the height is 0 at that point. So the work done is at point B. So at the work done at point B is kinetic energy, because it's maximum at point B. So my KE, my PE, which is kinetic potential energy, is mgh. That is not the PE. So my PE will give me m, which is mass of the ball 0.01 times gravity 10 times the height 25 cm, but convert it to meter, that means we are dividing it by 100. So this will cancel this. So my PE will give me 0.025 joules. This is now the potential energy at point B. So this is our YouTube channel. We call it STEM Up Africa. If you like what you are watching, we have other exciting videos on the channel. You can go through it, like, subscribe, and comment. Thank you for watching.